and slightly closer. If you have both less than or equal to, so that when equality is there in, so psi equal to eta, eta equal to zeta implies psi equal to zeta. So equality is a possibility when both the places equalities are there. Now we define what is a rational. That is what you mean by you are in Q. Psi is a rational if mod psi belongs to okay. You know that for any psi, mod psi is in R plus. Whether it is in, because you know that Q plus is contained in R plus, therefore if mod psi is in Q plus, then you say psi is a rational number. That is, psi belongs to what we call Q. That's the definition. Now, in fact, you need define it only for the other one is automatically defined. So this is it. So the relevance comes only when psi is less than 0. Okay, right. Yeah. Definition. So 0 is a rational. So 0 belongs to belongs to Q. See, this is for psi not equal to 0. So I'm right. So for psi less than 0. Because for psi greater than 0, it is well defined. Then you have psi less than 0 is said to be irrational if mod psi is not in Q plus. Okay, that is, it is not rational. Then you have what you call, you further define psi plus x if equal to eta, then x is defined as or written as eta minus. So this is a standard definition. Okay, right? Now we also want to say what happens when it's a whole number. A whole number is essentially an element of n. Okay. So we say that psi less than or equal to 0, definition, is an integer or what you call a whole number. If psi equal to 0 or mod psi belongs to. So if mod psi is a natural number, then we say psi less than or equal to 0 is an integer, or when psi equal to 0, then it is also an integer. Okay. So that belongs to, that defines everything. Now what you have is every whole number is rational, every rational number is a real number. So we have now extended the notion of order to the whole of R. We had it on R plus, so we now have this. Now what is the next thing that you have to do? You have to talk about addition, you have to talk about multiplication. So we'll build up that. Now all this, what I am saying is, this is not something that I have secretly worked. Some definitions are there. Then here we have some results on R plus, we have some results in Q plus, we have some results in N. So based on that, you have to prove every one of these statements. Now we define addition. See, on R plus we have addition. Well, that is well defined. Right? Okay. You remember we introduced psi and eta as cuts, which corresponds to some subsets, and then we have defined what is psi plus eta. That we have defined earlier. Now we will give the formal definition of addition. So the formal definition of addition is a very longish thing that you have to write down. Okay, so we will do it in various cases. For various cases. Okay. For psi less than 0, eta less than 0, I mean that is where we want to really work on. So we have various situations like, we are on the real line. You have 0 here, 1 here, 2 here, etc. You have -1 here, -2 here. Now everywhere here you have points filled, and correspondingly everywhere, because this is just a reflection of that, everywhere there you have the corresponding what is called the negative numbers also. Okay, but we have only addition defined here up to now. Now we have to say how we are going to extend addition on the other side. So using the addition that you have on this side, you have to extend it. I mean, that's the important thing that you have to notice in mathematics. Okay, you are doing a new thing now. When you do the new thing, you use all the old things, I mean, that are already available. You cannot suddenly make a jump. So you will have to stick to what you already know. That's very important. So let us see how this comes. It's very interesting to see how you write it. It is done in a very natural way. So you write this as minus of, just watch what I am writing, mod psi plus mod eta whenever psi is negative, eta is negative. Let us try to understand this. This is a definition. When both psi and eta are on the other side, where we have not said anything about addition, how do you define addition? You know that when psi is less than 0, eta is less than 0, you know that mod psi is positive, is in R plus. Mod eta is in R plus. And in R plus you know addition, therefore mod psi plus mod eta is well defined. Okay? So you go from psi and eta on this side, go to mod psi and mod eta, add them there, find out their sum, and then what you do? You go for its reflection. So that's what you have here. When I write minus of mod psi plus mod eta, you see I do only things that I can do. Already know. This is the definition. I am extending it for these numbers. What I do is I take mod psi, I take mod eta, both of them are in R plus. In R plus you know how to add them. So you add them and then go for its corresponding member minus of that. So that's what you define. So this covers all psi and eta which are negative. Now you have got this R plus and R minus, you have fused them together. So you have a 0 coming in, all these things are there. Therefore we have to be very clear about what you mean by the sum. Suppose when one of them is in R plus and the other is in R minus, one of them is 0. Okay, so all these cases we have to work out. Now we know that this is equal to eta when zero, but with the condition that mod psi eta is negative and mod that's the case for that. Now this is equal to 0 whenever eta is negative and mod psi mod. Okay, and let me write down the third one also, that this is equal to minus of mod e mod psi whenever psi is greater than 0, beta is less than 0 and mod psi is less than mod. Let's examine this definition. So what does this mean? Psi is greater than 0, that is psi is in R plus, eta is negative, therefore mod eta is in R plus, and suppose mod psi is equal to mod eta, And when you add them together, so it's something like saying psi and minus psi together, so you get 0. Okay. For example, let us start putting values for this. Okay. Suppose psi is positive, so psi is equal to 2. Eta minus 3. Then this is equal to mod psi minus mod eta. What is mod psi? Mod psi okay. I am taking with the additional condition. So this is not the case. So we take this as psi is equal to minus 5 or psi equal to 5 and eta equal to minus 3. Okay. And then I have automatically mod psi is 5 is greater than mod eta, that is 3. In that case, what do I define this to be? Okay, I define this to be, when you add these two, what you get? You get 2. You have to get 2. So what do you have? Mod psi is 5 itself, minus mod eta. Mod eta is what? 3. So it is 5 minus 3. Now you see that from addition you also defined subtraction under some conditions. Okay, earlier. So this is well defined. Okay, whenever mod psi is greater than mod eta, then this is well defined. Now when both psi is positive and eta is negative, when their absolute values are equal, then you define this as 0. These are definitions. Now you have psi positive, eta negative, and then you have the, take for instance 3 and minus 5. Okay, so you have mod psi is less than mod eta. So 3 is less than 5. In that case, you write it as, you take mod eta is bigger than mod psi, therefore this is well defined. So it is some number in R plus itself. Take its reflection. That's what you define it as. This is some examples. Okay. Work it out. So this is defined for all these scenarios. Now there are other things there. So you write this as psi plus eta when both psi is eta is positive. Okay. Then you define this as beta when if equal to 0. You write this as psi if. So all the different cases have been covered. Okay, so all these are well defined, right? So for all possible choice of psi and eta, now we have defined addition, right? Let us. Once you have defined it, now what are the properties that you can prove? You can prove that there is commutativity. So psi plus eta is called the sum of psi with eta. We use the property of commutativity in Arcus and the definition to get this. It's quite easy to do. For various cases, you have to split it up and work on this. Now we define, that's the theorem that we have to here. Now we introduce a new definition. Define minus psi, define this as 0 if and this as modulus of psi if psi is negative. Okay, only these two things have to be defined. So this is the definition. That means if you have a psi somewhere here, then it is mod psi. That we have to, that will be the minus of that. Okay.